Okay, this next one has only one additional step. We have the quadratic equation and we have the linear equation, except the linear equation does not have x or y by itself. So we need to isolate either the x or the y. So I think it's going to be easier here for me to just add y to both sides and get that x is equal to either 3 plus y, or I always like to have the variable first, so y plus 3. So now I know that x is equal to y plus 3, so I'm going to replace the x in that first equation with the y plus 3. So instead of x minus 2 in the parenthesis, in for the x I'm putting y plus 3 minus 2 squared plus everything else is coming down. I have now eliminated two variables by getting rid of the x. So now we just have y. Everything now is exactly the same as the last problem. The only extra step was here to get x or y by itself. So now I'm going to simplify what was inside this parenthesis, and the 3 minus 2 just gives me plus 1 squared, and I have the y plus 3 squared equal to 4. So I'm going to square both of those binomials. Y plus 1 times y plus 1, y squared, y, and 1 times 1 is 1. Simplify y plus y, so I get y squared plus 2y plus 1, and that comes down in place of the y plus 1 squared. Plus sign comes down, and now I'm going to square the y plus 3. So I have y plus 3 times y plus 3, y squared, 3y, and 9. And then simplify the like terms. I get y squared plus 6y plus 9. And that's going to replace the second binomial squared. And then in the same step, I'm going to subtract 4 from both sides so that I have my equation set equal to 0. Now combining the like terms, I get 2y squared plus 8y plus, I have the 1, 9, and minus 4. So I get plus 6 equal to 0. And again, I could divide both sides by 2 and get rid of that leading coefficient, making it easier to factor. If you're just graphing it, you actually don't even need to do that step. You could graph and get the x-intercepts here before even dividing both sides by 2. But since I'm factoring, I wanted to divide both sides by 2. I get y plus 3 and y plus 1 equal to 0. So if I continue down with that, I get that y equals negative 3 and y equals negative 1. So now I have to replace both of those into the linear equation. So let's go back. X minus y equals 3. So x minus y equals 3. I'm going to replace the y first with the negative 3, my first solution here. And when y is negative 3, the equation looks like this. So I'm going to make this x plus 3 equals 3. If I subtract 3 on both sides, I get that x is equal to 0, giving me my first solution is 0 comma negative 3. Remember, x goes first. Then, in that same equation, I'm going to replace the y with negative 1, because we also got that y is equal to negative 1 over there. The minus, I'm going to rewrite that as x plus 1 equals 3, minus 1 on both sides, and I get x equal to 2. So 2 negative 1 would be the other solution. I'm sorry that my work isn't as clean as I'd like it to be, but I do already have this typed into the calculator as a way to check, and I put the two equations in, and the points of intersection are at 2, negative 1, so that's the solution here, x2 with y negative 1, and my other solution here is 0, negative 3. When x is 0, y is negative 3. So you could see it graphically as a way to check, but if you're asked to do it algebraically, you need to be able to show all these steps of eliminating one of the variables, getting one of the variables solved for first, plugging that in, and getting the other. So you guys are on your own for number 3. Bye-bye.